This next one is an assigned homework problem, and it's one for you to try, problem 49 from the homework. Same directions we've been doing throughout. Again, make sure you're reading the directions in the book. Sometimes the book just asks for solutions from 0 to 2 pi. I've been pretty consistently asking for solutions from 0 to 2 pi and then all solutions as well. Do remember that you're listing what x can be. Here in this equation, I see that the input to cosine isn't just x. So this is going to be one that you're going to need to use some identities to rewrite things first. I do just see one trig function. I just see cosine, but I see two different angles. I see 2x and 4x, and they're connected by subtraction. So there's no way I'm going to be able to separate them into distinct factors. So you're going to need to use some sort of a trig identity so that you can get everything to just using one trig function of the same angle. Okay? So see if you can do that. Pause the video, tune back in, and we'll work through it together. All right, so my goal is going to be so that I get this to be just one trig function of one angle. That angle does not have to be x. I'm going to actually try to get this in terms of just 2x, because notice 4x is just twice 2x. So if I use the double angle formula here, I should be able to rewrite that first term in terms of cosine of 2x. Then I can solve for 2x. And then once I know 2x, I'm going to get x by cutting it in half. So let's see how that works out. I'm going to just write over here the double angle formula. Now I'm going to write it as cosine of 2a, just so I don't get confused. I actually am happy with 2x right here. I'm viewing that as two copies of 2x. So essentially my a here is 2x. Cosine of 2a, remember, is cosine squared a minus sine squared a. That version's not quite so helpful because it has two different trig functions in it. But I can see I've got some cosines already, so let's try to just get rid of those signs. So this would become cosine squared a minus the quantity 1 minus cosine squared a. And when I distribute the negative, the 1 is negative, the cosine squared becomes positive. So I get 2 cosine squared a minus 1. Okay, so recognizing that my a, the thing I'm doubling, was 2x, I can now rewrite that first term as 2 cosine squared of 2x minus 1. And then I've got the minus cosine 2x equals 0. So now the only trig function I'm dealing with is cosine, and the only angle I've got is 2x. So there's no need to use the double angle formula to reduce it all the way down to x. I just needed to reduce this one to being doubling 2x. Okay, I'm going to just rearrange the terms. I usually have the squared term, then the trig function, then the constant. So I'm just going to swap the order of these two. So 2 cosine squared 2x minus cosine 2x minus 1 equals 0. And let's just remind ourselves, even though the question is asking for these two things, I'm actually going to answer the question through a 4-step process, because I'm first of all going to figure out what this angle 2x is. So I'm first of all going to find 2x in the interval from 0 to 2 pi. Then I'm going to find all possible values of 2x. Then I can cut those in half to get all possible values of x. That's actually part B here, which I'm going to end up doing first. And then I can get the x values in the interval from 0 to 2 pi. Okay, so these two preliminary steps are where I'm going to be doing most of the work, but then I need to make sure that I actually answer the question. And the question, if it was solved this, was what can x be, not what can 2x be. All right, so let's hope we can factor this. Okay, so I'm hoping that that's the result of foiling. If that's going to work, in order for my first term to be 2 copies of cosine squared 2x, I'm thinking I need 2 cosine 2x and cosine 2x. And then for the last terms to multiply to give me a -1, I'm needing one positive one and one negative one. And then I want them to combine so that the OI, the outsides and the insides, is negative cosine 2x. Looks like if I put the -1 here and the +1 here, that'll do it, because that gives me -2 copies of cosine 2x plus 1 copy of cosine 2x. That's going to combine to give me -1 copy of cosine 2x, and then my last terms do in fact multiply to give me -1. Excellent. So now I can set each factor equal to 0. So either 2 cosine 2x plus 1 equals 0, or cosine 2x minus 1 equals 0. In both cases, I want to just isolate the trig function. So here, I'm going to subtract over that 1 and divide by 2. So cosine of 2x would equal -1/2. Okay, so let's go ahead and solve that one. Thinking in terms of quadrants, cosine is negative in quadrant 2, and it's negative in quadrant 3. And I'm just being very careful to label my angle 2x so that I don't think once I find those values that I'm done. That's going to be up here in this first step. I've got a ways to go before I get down to x. Okay, so those are my quadrants. In both quadrants, we're going to have the same reference angle alpha, and I know that cosine of alpha will be the absolute value of -1/2, which is just 1/2. 30, 60, 90. And again, probably a lot of you at this point don't need to even draw this or look at your unit circle. Probably a lot of you just can say right off the bat, oh, that's going to be 60 degrees or pi over 3. And that's totally fine. And there's nothing wrong with needing to draw this. It should be a fast process. You should recognize, oh, that's one of the nice ones, and you should be able to get there fairly quickly. But if you need to draw the picture to get there, I don't see any problem with that. Okay, so my reference angle here then is 60 degrees, which is pi over 3. Now for this picture, I've got that 2x is pi minus alpha, so that would be 3 pi over 3 minus pi over 3, so that would be 2 pi over 3. For this picture, I've got that 2x is pi plus alpha, so that's going to be 3 pi over 3 plus pi over 3, so that's 4 pi over 3. So that's two solutions right there, but those are values that 2x could be. So I'm very carefully labeling that. Those aren't values of x, they're values of 2x. So that was 2 pi over 3 and 4 pi over 3. I got those from setting that first factor equal to 0. Second equation we have is cosine of 2x would equal 1 if I add that over. Now that's going to tell me that we're at a quadrantal angle. That's the biggest value cosine ever takes on. And the only place on the unit circle where the capital X value is 1 is here. The only angle in this interval that lands there is 0. So this would be 2x equaling 0. I'm not listing 2 pi, and that's because this was a parentheses here. And of course the reason it's a parentheses is because that's coterminal with that. I'm about to get all values of 2x by adding a multiple of 2 pi to these solutions. So I will get 2 pi. It is an answer. I'm just going to get it by adding 2 pi to that one. Okay, so all values that 2x could be are going to be 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and 0 plus 2 pi n. And I don't really need to write the 0 plus. I can just write 2 pi n. I do want to make sure that I say that n is an integer. Okay, excellent. That's most of the work here, but we don't have any answers yet because we were asked what x is, and we found what 2x is. So I'm going to find all x, and I like to just write out the first one, even if after that I feel comfortable doing the rest. in my head. Just to give myself some more space, I'm going to write all x over here since this was getting a little bit cramped. Okay. Here, with this first possibility for 2x, I was saying 2x is 2 pi over 3 plus 2 pi n. I know how to solve for x. I'm going to divide by 2, but that means I have to divide both pieces by 2. Okay. And that's why it's so important that you remember to add the 2 pi n first, because 2 pi, that was the period for cosine. But I'm working with cosine of 2x. The period for that is pi. Now notice, if I divide through by 2, now here I might write that as multiplying by 1/2, and here I can write that as dividing by 2. Those 2's will cancel, so I'm going to get pi over 3 plus pi n. Notice now I'm adding a multiple of pi. That's the period for cosine of 2x. So this adjusts so that I'm not adding the period for cosine of x, I'm adding the period for cosine of 2x, which is what showed up in my equation. Okay, so I get that. So let's write that up here, pi over 3 plus pi n. I can then do the same thing here. 4 pi over 3 plus 2 pi n. If I divide that, that's 2x, so if I divide that by 2, I'm getting my x values. That would be 2 pi over 3 plus pi n. And then 2 pi n, if I divide that by 2, I'm going to get pi n. And again, want to make sure I record that n is an integer. Okay, fabulous. So now we want, this was essentially my answer to part B. Now I want x values in the interval from 0 to 2 pi. Okay. And so I can list what we found so far, pi over 3. Oh, actually, you know what? I'll list it as we come up with it. Never mind. Okay, so I'm going to just create a table, although again, it's not absolutely necessary, listing my values of n, and then this first thing, pi over 3 plus pi n. Want to make sure I'm listing my x values. I initially pointed up here, and then realized I was pointing to 2x. I wanted to be pointing to x. One reason it's super important that you label things, because you've got a lot of information going on here. Okay, now if n is 0, that's just going to give me pi over 3. That's going to work. If n is 1, I'm adding pi to that. That would be 3 pi over 3, plus pi over 3 would be 4 pi over 3. And if n is 2, I'm going to be too big, because that would be pi over 3 plus 2 pi n, or sorry, plus 2 pi. That's bigger than 2 pi. Okay. So from this general form, I got two answers, pi over 3 and 4 pi over 3. Now I can do the same thing here. So I've got n and 4 pi over 3 plus, I'm sorry, I keep looking here, and I shouldn't be looking here. I should be looking here at where my x values are. So it's 2 pi over 3 plus pi n. If n is 0, I just get 2 pi over 3. That's definitely in the desired interval. If n is 1, I'm adding pi, or 3 pi over 3 to that. So that would be 5 pi over 3. And if n is 2, that's too big. So again, we got two answers there. So we've got 2 pi over 3 and 5 pi over 3. Okay. And then we've got, whoops, and then we've got pi n is our last one. I'm going to again just create a table. The table is optional. If you feel comfortable just sort of running through, n is 0, I get this, n is 1, I get that, n is 2, too big. You don't need to have that table, but it just helps me keep track of what I'm doing. So I'm going to list n and then pi n, this possibility for x. If n is 0, I get 0. That's in the interval. If n is 1, I get pi. That's in the interval. If n is 2, I get 2 pi. That is not in the interval. That's too big, because we didn't include that. Okay. So I have 6 values that x could be in the interval from 0 to 2 pi. Okay. Not too surprising. We had 3 values that 2x could be. And remember, we've discussed the fact that when you look at cosine of 2x, you're going twice as fast. So you fit 2 periods in the same interval. So if in one period you had 3 solutions, in 2 periods you're going to have twice as many, so we had 6 solutions here.